Hello everyone and welcome to another video. So today I'm going to be continuing and finishing the chapter 14 notes over acid and base reactions. I'm going to cover three types of reactions. The first, acid and water, the second, base and water, and the last one, acid and base, which is a neutralization reaction. So let's start here with the acid and water reaction. So remember, the acid will dissociate. The degree to which it dissociates depends on whether it's strong or weak, which will be indicated by these arrows. Okay? Now, the water will gain a hydrogen that dissociated from the acid. Remember, acids usually have almost all the time an H in the front of them. So when that dissociates, that H will become a part of that H2O to form a hydroxide ion, which is H3O+. You can see that in this illustration here with water and HNO3. So this hydrogen here, when this dissociates, will become a part of that H2O, and that's how you get the H3O+. And now left over you have that NO3 minus 1, which is a nitrate ion. This example is actually for a base, and I will talk about this example later on. That's actually for a weak base, which we'll get to later. So regardless if the acid is strong or weak, the way in which you will write your products will still be the same. So let's start with the first one. So HI and H2O. So this is a strong acid. And we also know that from this arrow right here. So this will dissociate. You'll get that H plus and that I minus ion. And again, that H will become a part of that H2O. So you get H3O plus. Plus you get the iodine ion. So we can write minus 1. And that is it. Make sure that it's balanced on either side. In this case, it already is balanced, so we do not have to add anything. Now, for this next problem, this is a weak acid, and that's why we have this arrow here, the two-sided arrow here. And I'm going to go over what we're going to do in this situation when we have H2 instead of just one H. So when this one actually dissociates, you still get one hydrogen ion, but one of those hydrogens will stay with that SO4. And this hydrogen will become a part of that H2O. So you get that H3O+. Plus now left over, you have HSO4. Now this might look a little weird, but if you go to your chart here, you can actually find HSO4. That is an example of a polyatomic ion. So HSO4, and that has a charge of -2. Okay, so this one is -1. Okay, so again, make sure that you guys are referring to your polyatomic ion table. It will be very helpful. And this one is actually already balanced as well, so we do not have to write anything. So for reactions with water and acid, the H from the acid will become a part of the water to form H3O+, and then you just have to make sure you write the ion that is left over. Please do not forget to write your charges because these are all ions. Now, the next example is going to be for our base and water reaction. These two will differ a little in terms of the strong versus the weak base. So for the first one, your strong base, again, we know this because of that arrow, and also this is a metal hydroxide. So these are really straightforward. All you're going to do is disassociate this So you get that calcium ion and you get that hydroxide ion. And this hydroxide ion will not interact with the water at all. So it will just actually stay disassociated. And you can actually see that in this image right here. Notice that the NaOH in this example, for that metal hydroxide, it just disassociates and it just stays disassociated in the water. So you would get calcium that has a charge of +2. Your hydroxide ion, that is a charge of -1, and the water. And that is it. The last thing we have to do, though, is make sure this is balanced. In this case, I have to make sure I put a 2 in the front here. So we have the 2 OHs on this side, so I have to make sure I put a 2 in front of the OH on this side. And now we are finished. So these are pretty straightforward for the strong bases. Now let's go over an example when we have a weak base. So NH3, that's an example of a weak base. Now notice we don't see OH. You're like, well, OH is what makes something a base. So we have to figure out, well, where are we going to get this OH from? So in this situation, the water, one of the hydrogens from the water, will actually become a part of the weak base. Because if water is normally H2O and it loses a hydrogen, you would just have one H and one O, and that's your hydroxide ion. So that's how we get that hydroxide ion. Well, now that other H is now part of the NH3, so now it becomes NH4, and since it gained that hydrogen, it's going to have a charge of +1. And this one is actually already balanced as well, so we do not have to balance it. And also, you can see an example of that here, and that was this example up here. So again, this is a weak base. It is reversible. Notice that the water became that OH by losing its hydrogen and giving it up, okay? Versus our strong bases, they simply just disassociate, and you have to make sure you write the water. And then this, of course, is another representation, a Lewis dot structure representation, if you guys remember that. Again, that hydrogen from the water will become part of that base, and that's how we get our OH. So those are base and water reactions. Now for the last one, we have neutralization reaction. So as that name suggests, you're going to create something that's neutral, and water is an example of something that is neutral. So this is what happens when you combine an acid and a base with each other. So I'm going to go over 2 examples here. So one thing to remember with a neutralization, if you're ever stuck, just start by writing water. You know that that has to be one of the products. Again, we know this is an acid because we have that H in the front. We know these are bases because they end in an OH. Now, these acids and bases will dissociate. So when they dissociate, the hydrogen from the acid and the OH from the base combine together, and that's how you get water. And then whatever else is left over, that is going to be your salt, okay? Now, you have to make sure, though, that you do your crisscross. So I'm just going to show my work over here. So we have Na left over and Cl. Again, make sure you write the metal first. Na is +1, Cl is -1. We do the crisscross. We get NaCl, which is literally salt, okay? Again, if you guys need those charges, refer back to your periodic table charges. These are all the polyatomics down here, and then for all the other elements, they are up here. And this first example is actually already balanced, so we do not have to do anything. Now for the next example, this might look a little funny just because earlier when I was doing the example with the acid, I said, oh, only one of them disassociated. That was because that reaction was happening with water. In this case, since we have an acid and a base reacting together, that will completely disassociate. Okay, so don't worry about that too. We'll take care of that later when we balance it. So now the things that we have left over in this case, we have that Na and we have SO4. So Na, we already said that has a charge of +1, and the SO4, let's go back to our chart right here. So if we find SO4, that has a charge of -2. So -2, we do our crisscross, so we get Na2, SO4. And the last thing we have to do is balance this. There's actually a typo. There should be a 2 here in the front, okay? Now, the last thing we have to do is make sure that this is balanced. So we have 2 Na on either side. We have 1 SO4 on either side. And we have 2 hydrogens here. And we have 2 hydrogens here, okay? But we also have to keep in mind we have this hydrogen here, okay? So now we have to keep in mind that we have this 2 in the front here, okay? So in this situation, here, let's pick a different color. So you have 2 hydrogens here, and then you have to make sure you keep in mind that 2 gets distributed. So you have a total of 4 hydrogens on this side, okay? Now, since you only have 4 you have 4 on this side and you have 2 on this side, we have to put a 2 in the front here, which works because now we have 2 oxygens and we have 2 oxygens on this side. Again, the reactants will always be balanced for you, so that 2 should have already been there, and then the only thing you had to do is put a 2 in front of the H2O. And one last thing to remember is for a situation where you do have a polyatomic ion, and let's say when you do your crisscross, there will be a number here, make sure that you put your polyatomic ion in parentheses. If you want to put it in parentheses every time, just as kind of a safe precaution, you are more than welcome to do that. And those are your 3 types of reactions.